Today we're trying to answer the question, what is soil health? Soil health is a large umbrella term that has a lot of different meanings to a lot of different people, and we're trying to narrow down the essence of what we can measure and what we can manage to increase the soil health on our farm. So we know the benefits of having healthier soil. Improved nutrient cycling, meaning our nutrients can be saved in our soil. They're locked and unlocked at the correct times. We have improved soil structure and aggregation. Our soils can flocculate and create a structure that allows our crops' roots to dive as deep as they can go to access more nutrients and more water. We have increased water holding capacity. The water that we get through irrigation or rainfall events is able to infiltrate deeper into our soil savings account instead of running off farm. Microbial abundance and diversity increases as our soil health increases. The amount of microbes that are working in our soil's engine to make nutrients available to our crops exactly when our crops need them allow for us to decrease dependence on off-farm inputs. Now that potential downside is decreased as our farm is more resilient because of these outcomes of having healthier soil. So we know that that's the case, but in an agricultural context, what can we measure and what can we manage so we can increase our soil health? Under the umbrella term of soil health, what are the things under that umbrella, right? What are we measuring? What do we know are proxies that, if increased, lead to these outcomes, right? And then what are the practices that we can manage that we know influence what we've measured? So oftentimes when we think of soil health, we think of large programs that are trying to get farms to change their practices, and it can get pretty muddy. So when we hear practices that improve soil health, generally what you'll see in every single list will be ideas like cover cropping, reducing soil disturbance, doing rotational grazing, and maybe using alternative inputs or input reduction. These are all practices that need to be very much distilled down into specific management ideas that make sense for a specific operation in their context, right? These are fairly broad ideas that may or may not work in different operations. And what we want to look at is less about specific practices, although they're very important and are a good guide. We want to look at the measurable quantitative metrics that we want to see improve, that we know lead to increased soil health. We have ideas like organic matter percentage. It takes quite a while to raise that over time. With new testing methodologies and new tests coming onto the market, there's a host of more data that not only we're looking at as Cultra, nutrient analytics company, but also that we're seeing the USDA look at. We're seeing people at the NRCS office requiring. And if we want to be compliant in any program that we want to be into, or even if we just want to increase our soil's health so we have all of those beneficial outcomes that we mentioned earlier, we want to be looking at these metrics as well. We also have soil carbon. Now, generally on a lab test, there are a bunch of different things that we can specifically measure that are estimating, is our soil carbon increasing, right? And when we think of soil carbon, we want to think of it as microbial food, because that's the driver of increasing soil health, which is increasing the abundance and diversity of our soil biology. So the biology is the centerpiece of soil health. We want to make sure that that biology is supported. So we want to create an environment that supports that biology, and a key piece of that is having the food needed to support a high diversity of that soil biology. And that's why you're going to see soil carbon show up in a host of different ways. We're going to see things like WEOC, water extractable organic carbon. We're going to see things like a carbon to nitrogen ratio, and a host of other kind of broader ideas on how we can increase the food for the biology so that biology can explode in population and lead to increasing soil health. Because if we get biology correct, right, if we make a home for the biology to thrive, that's what generally is going to create a lot of the downstream impacts we see on soil health. We want to know if the practices we're doing are increasing the quantitative metrics that we're looking at that we know over time increase our soil's health, right? So what are these quantitative metrics? We're going to be looking at physical quantitative metrics, chemical quantitative metrics, and biological quantitative metrics, right? So for instance, just a quick overview, physical is going to be things like compaction. You take a penetrometer, you put it in your soil. What does that penetrometer say? And is that number going up or down, right? Ideally, we want our roots to be able to penetrate deep into our soil as easily as possible. And then we're looking at chemical quantitative metrics. Those are going to be like the nutrients in our soil. Is our soil balanced, or over the past 50 years has a heavy amount of inputs influenced it in a certain way to move it away from what would be optimum for our soil's biology and for our crops, right? We're looking at things like nutrient antagonisms that could have appeared and other key soil balancing aspects that we can deduce from looking at a soil test, right? But that's not the whole picture. The whole picture is when we include biology, because they're all connected. We might see these three in something like this, right, where we have physical, chemical, biological, and then soil health, right, as a collection of all three of these. But what I've been hearing more and more, and what I think is closer to the truth, is more something like this, where this is biological, and then we have physical, and we have chemical, where biology is the driver of everything else. And if we focus on increasing our soil biology, that will remove many of the bottlenecks. Now, it's important to understand that in a heavily biological system that could have been amended with years and years of compost, I've seen this plenty of times working on small scale market gardens and growing vegetables for chefs and things like that. If you're putting on tons of manure to try and increase the biology, sometimes we could be applying excesses of specific minerals. And so then our chemical balance can get out of whack. So it's incredibly context specific to figuring out where your specific contextual bottleneck is. And unblocking that is going to allow for a lot of these key metrics to increase. We can figure out what that bottleneck is through measuring and managing, right? That's the name of the game with soil health, is measure and manage and look for the bottleneck that, if unblocked, would have the highest leverage and therefore the lowest cost to outcome that we can do over time, over and over and over again. And if you come into a bottleneck, you measure and manage it and make that not a bottleneck anymore, and you find the next bottleneck, you measure it, you manage it, you increase it. If you do that over and over and over again, your soil health is going to improve. I was at a talk where the speaker was saying that we should not be looking at soil health in this way, and we should more so be looking at soil health in a microbial, biologically dominant way. And I think it is a mix of multiple depending on your specific context. But what we want to look at are, if we're measuring and managing, what are the numbers we're looking to improve? We have a couple lists for specific metrics. One of them actually comes from the USDA's website. So that's a leading sign that if we're looking to enter into any kind of soil health programs through the NRCS or something like that, those are going to be the key metrics that those folks that in their office that can stamp approved or not approved are going to be looking for. And so we're going to be talking about additional indicators that we also want to be measuring and managing to increase our soil's health. So if we're looking at physical measurements, we have a penetrometer reading. That's going to be our main thing we're looking at, and we want that to go down generally if we're in more compacted soils. But a lot of the physical characteristics are going to follow from having our soil chemistry balanced and increasing our soil's biology. So if we increase our soil's biology and we make sure that a mineral imbalance is not the bottleneck, then our soil structure will generally follow. A couple things we can measure, again, the penetrometer reading, and also looking at water infiltration rates. During a certain amount of a irrigation or precipitation event, how deep is the water able to reach in your soil? And that number is something that we want to improve over time. The qualitative metrics we want to look at that are a proxy to soil health are generally going to be metrics that are tied to biological potential. So we want to look at carbon. Carbon is, again, a super broad term. We're never just going to see carbon as a thing that's measured on our soil test. Like we'll see something like zinc. Carbon is going to be broken down into a bunch of different factors that correspond to characteristics of that carbon, right? So we can have like a savings account of carbon and a checking account of carbon with things like organic matter versus water extractable organic carbon. So these are generally going to correlate with microbial potential, so the food that your microbes have to eat and multiply. And we also want to look at proxies for the amount of microbes, right? And the diversity of microbes. Those two things are other quantitative metrics that we can look at through things like a CO2 burst, right? That's measuring our soil's ability to breathe, which is a proxy measurement for the amount of microbes that are in your soil. So this is number of microbes, CO2 burst. How alive is your soil? If you have more microbes, you're going to have more tiny little bodies breathing in and out, and therefore increasing the amount of CO2 over a 24-hour period that's created when you take a piece of soil and you put it in a little chamber and you measure the amount of CO2 that's created. We're going to get something like soil respiration. We're going to see that on a lot of these soil health assessments that you may have been seeing come up, either from Cornell's soil health assessment to Regen Ag Lab's Haney tests, to a host of other tests that you may be looking at doing on your farm. And then we're also going to look at microbial diversity. We can have microbial abundance, but we also have the other side of that coin, which is microbial diversity, which leads to things like an increase in disease resistance. Right? If we have a really highly diverse microbial population at our root zone, we're going to have way better disease resistance. And so we can look at things like a PLFA test, right? A phospholipid fatty acid test, which help determine the functional groups of microbes in our soil. This is incredibly important for looking at appropriate nutrient cycling depending on the contextual nuances of your operation, whether that be an annual row crop operation or a perennial orchard operation. We're going to want different functional groups for those specific contexts. And looking at increasing the diversity of those functional groups through things like PLFA and balancing those fungal to bacterial ratios and increasing the total abundance are all important for directly measuring the microbial abundance and diversity of your soil, which we know when that number goes up and to the right, our soil health goes up and to the right. So these are the quantitative metrics, and I really wanted to make a point of this because having these metrics at hand, having the results of these tests organized and this data organized and accessible is going to be key if we ever want to take advantage of any kind of program through the USDA or the NRCS. It's very important. So we have outcomes that impact our crops, right? Which are the outcomes we talked about earlier. Increasing soil resilience prevents potential downside impacts of extraneous variables. So that's things like drought, it's things like really heavy precipitation event, it's things like stress tolerance from cold, or the delivery of fertilizer, what's late, and like how good are your crops at being resilient to not getting exactly the nutrients they need at exactly the right time. If you have an increased soil health, your crops are going to have a higher level of resilience to any of those potential factors. There's also very awesome outcomes that we're seeing through a host of a bunch of different organizations trying to come together to help growers increase soil health, because it can be inconvenient to change management practices to try and increase soil health. Ideally, the benefits of soil health and what's needed in these programs, ideally they completely match. But I want to just go through a checklist on things that they say are important for soil health so that we're prepared, in addition to just managing our soil better, but able to document and prove that our soil health is increasing, because we can access a lot of benefits if we do that. What we're going to be looking at is a roadmap to increasing soil health. We're going to look at our soil's physical, chemical, and biological quantitative metrics. We're taking a standard soil test looking at our mineral balancing, right? That's one element. We're looking at specific biological indicators like our carbon. We're looking at our microbial abundance and diversity through things like soil respiration tests and PLFA tests, and other things that you may see on a soil health assessment that is offered by a lab. And we're looking at things like penetrometer readings. We're looking at things like tissue tests or plant sap analysis in season to see if our crops are getting the nutrients into the plant, right? That's our source of truth, is getting those nutrients into the plant. And so obviously we want to be looking at those as well to make sure everything stays on track. And once we've done some of this measuring, whether it's pre-season with these soil tests and microbial tests, we need to make a plan. What practices are you aiming to do? What are we doing? What practice are we going to be implementing? When are we implementing that practice? And where are we implementing that practice? It seems simple, but if you look at actual farm data, we encounter a host of problems. Like you had one retailer from previous year that did all of your soil tests and they named your fields a certain way, and then you switched retailers and now your field names are all completely different, and so you have no consistency on the where, the when the practice was done and it wasn't documented, and so now you don't know when it happened. And then the what, maybe you go out and you do something and you remember what you did, but it wasn't documented in a plan that you can give to somebody. We want to make sure that we're writing a management plan that's addressing the bottlenecks that we found when we measured. And so all of this is going to lead to increasing soil health. And so then we go into the third piece. After we've written the management plan, we're going to follow the management plan. If you're flying by the seat of your pants, then it's significantly harder to measure and manage and get a graph that goes up and to the right. But if we do our best to write a management plan so we know what we plan on doing, when and where, it's easier to follow that management plan. But that management plan does need to be followed to address what we found when we measured. And now, the fourth piece of increasing soil health is measuring again. A lot of times this one gets missed, right? But we don't know if any of this was worth it if we don't measure again and see a graph that goes up and to the right. So we want to be looking at creating this graph in our soil, meaning we're going to measure, we're going to follow the management plan, and then we're going to measure again, and we're going to look at this difference. Is this going up or is this going down? And that informs us that for the next season, when we measure and write a management plan, should we follow what we wrote last season, or did our number actually go down and maybe we need to make some tweaks, right? If you're doing things season after season after season and each season you're looking at a snapshot, you're not seeing the trend. Maybe this graph for the past 50 years has been looking like this. And where's it going to go if it's not measured and managed and checked to make sure that it's not going down over time, but we're changing the slope to go up and to the right? And so that's our goal. We're going to document all of the data in these 4 steps. So we're going to measure. That's generally going to be sending samples to a lab, getting that data back, organizing it, maybe in a spreadsheet, maybe in a software like Cultra. We're going to write our management plan, again, maybe in Google Docs, but maybe in Cultra. And then we're going to follow the management plan, and then we're going to measure again, and we're going to assess, did our graph go up or did it go down? I know this is incredibly simplistic, but writing all of this data down and having it stored and organized is always going to be helpful. We want to know if all of this energy that we're spending time on to try and accomplish this goal, are we getting closer to that goal or are we moving further away from it? And we're not going to know that unless we do these 4 steps. Most programs that we see that are trying to help increase soil health are going to be following these 4 steps, which have a combination of outcomes and practices. Our outcomes are going to be from this 4th step, measuring again, so we can create a graph over time. It's going to be our outcomes. And then our practices are our contextual things we're doing for our specific operation that are written down in a full management plan. Oftentimes it's going to be a nutrient management plan where the focus is on fertility and on fertilizer applications. And then we're going to make sure that we follow the management plan. So anytime one of those actions or those practices is done, writing down what was done, when it was done, and where it was done. If all of that is completed and organized and just becomes a part of what we're doing, I have no doubt that soil health will increase. In this last section, we're going to talk about specifically writing nutrient management plans or management plans in general for the USDA/NRCS. We've seen in the news the $700 million pilot program for regenerative ag. We also have a lot of NRCS programs that are underutilized through things like the EQIP program. And what I want to talk about is the data that you may need to collect or begin to start looking at and documenting. So when you're writing your management plan to submit to the NRCS, you're armed with all of the information that you need to know. So I'm going to tell you what they care about and some details to keep in mind. Earlier, we were talking about we measure our soil health, we write a plan, we follow the plan, and we measure again. We can kill two birds with one stone here when we're writing that plan by writing a plan that's submittable to these organizations. So we have your management plan, which is your practices, your specific context, and then we have details that if we include them, will increase the probability that you'll be able to take advantage of some of the funding through these programs that you may not instinctively include on your specific management plan. So my goal here is to explain some details that may help explain what the USDA and NRCS is looking for, specifically in regards to key pieces like phosphorus and nitrogen runoff and overall land stewardship and other details in relation to local natural resources. So we have our inputs, that can be manure, fertilizer, chemical inputs that we're spending dollars on keeping on our field for our crops. And the goal when running these plans for the NRCS is to show how we're doing our best to prevent any of those inputs from leaving the area where we want them into an area where we don't want them, which is generally going to be local bodies of water and other natural resources around the land that we're farming on. So we have different management zones on a farm that we manage in similar ways based on differences in soil variability and other factors. And this plan is saying, here's what we do that's the same across these fields, and here's what we do that is different across each one of these fields. And so it's really important that we have consistency in our field IDs. So what we're talking about when we say something like, oh, the field behind John's mom's house, right? Is John's mom's house what you put on the soil test last season and this season when we're writing this plan? When you see that and you see a phosphorus value that corresponds to that field ID, they need to know what you're talking about. And oftentimes you're going to have 25, 30 fields. So it's really important that this data stays clean and consistent in what field ID you're talking about year after year. Now, each one of these fields, zones, management blocks, oftentimes get broken up. Sometimes they're grid sampled or zone sampled or however you're putting them together. But oftentimes what they're looking for is the average of an area. So if we have one field that gets grid sampled on, say, 5-acre grids, and this is a 100-acre field, right? That's 20 soil samples for this field. For the purpose of a USDA NRCS management plan, we're going to generally average our soil test values in order to assign nitrogen, phosphorus, potassium amount to the field ID that we're talking about in this management plan. So the goal of the NRCS is to make sure that the fertility that's being applied to the field isn't leaving that field and entering into a natural resource like a body of water. And so what they're going to look for on these management plans is what's the measured NPK of this field and what's the applied NPK and how did you get to that number? They just want to make sure that it's rational and it's using a logic that makes sense that will prevent, any kind of off-farm effects. The standard method that they generally will use is a land-grant university. You may see this as LGU. So I'll write kind of an example of what they like to use. Not necessarily what's most agronomically sound, but it is what they use for these plans. We're often going to see matrices like this where we have our measured phosphorus value, our measured potassium value, and both of those are going to be rated based on land-grant university research from low to high. And in each one of these boxes is going to be a recommended rate. It'll look something like this with each one of these boxes filled in with NPK rates that they deem ideal. So for potassium, if your field has very high potassium, it'll probably fall in the NPK rate where they recommend no additional fertility be applied using potassium. And you can find these matrices, they're kind of hidden, but if you look up crop nutrient requirements with your state's land-grant university, there's generally going to be like a long PDF online with every single crop's matrices like this. And if you include a matrices like this in your nutrient management plan, that shows the NRCS agent that's on the other side of the table reading your proposal that you used their resources in order to generate this plan, and it increases the odds of this plan going through and you getting access to that capital. But the problem often arises where if you went off of that matrices, it may or may not be the most agronomically sound rates for your specific context and your location with the crops that you're growing at the yield goal or your desired yield that you want. And so what do we do about that? Oftentimes, if you read through the dense paperwork that they've put out, you'll see things like nitrogen-based management or phosphorus-based management. And what they're saying here is they're evaluating the risk of runoff between those nutrients. And what I'm gonna go through is kind of how they like to view and how they come up with those risks. The phosphorus-based management is something that they'll recommend if you have a high risk of phosphorus being applied to the field that they think has a high risk of leaving that field and entering into a body of water. For a high phosphorus risk index, or a nitrogen leaching risk, or something with those types of terms, they're going to look for things like your measured NPK from a soil test. And if your phosphorus level is 1,000 pounds per acre or something very high from years of manure applications or something like that, they're going to see that number and then compare it to a list of risk metrics. So those are things like the slope of this field going towards this body of water, how many feet between our, what we call our spreadable area, the applied area of fertilizer, that field, how many feet that is away from a body of water. We're going to look at things like water infiltration rates, erosion rates per year, and a bunch of other metrics. You can often find those metrics if you go to the USGS Web Soil Survey and you draw out that field. It'll have the list of all of the metrics that the USDA asks for. And oftentimes, taking a screenshot of that drawn field on USGS, you can upload that into your plan and say, here's my field, here's the field ID, here are all of the key details around it. This is why I'm applying this amount of fertilizer in this area. And here's why I don't think it's a risk of any of that fertilizer or off-farm inputs from entering into the natural resources around my farm. And that will help get them across the line to approving that proposal. These plans are written with your local NRCS agent. The reason I'm talking about all of these details is because you don't want to waste time going to the NRCS office or having the NRCS agent coming out and kind of introducing all of these. If I can arm you with enough information, then you can take the least amount of time helping your NRCS agent write this plan. And then maybe even you can write this plan that's tailored exactly to your specific context, armed with this information, so you can submit it to your NRCS agent to stamp and to go through with you, and then submit it to be assessed to eventually hopefully get you some of that capital. As we all know, the USDS and the NRCS love the 4 R's. So do we. Right rate, right time, right place, and right source. We want to say, we're applying this amount of this product that has a guaranteed analysis of this NPK, right? So like a 20 at a pre-plant 400 pounds per acre. And we're going to list all of our fertilizer or input timings corresponded to a place with the source and the rate. It's really helpful that these details are documented somewhere. Maybe you can access them from a John Deere Ops Center console or wherever else you keep these notes. But knowing that these are the things that they're looking for when we're writing these nutrient management plans for EQIP and NRCS is going to make your life a lot easier if you want to enter into any of these programs. So when you're writing this nutrient management plan, a lot of times you can kill 2 birds with 1 stone by writing a plan for yourself, so you know exactly what you're measuring, where your bottleneck is, how you're going to take care of it, and then when you measure again, you have detailed data in order to assess whether your soil health went up or it went down. While we're doing that, we can access government funds through government programs with the NRCS if we make sure our data and our details that we're capturing in that plan match with what they're asking for. And if you look up things like the NRCS 590 nutrient management plan, they'll have a whole long list of things that they need in order for that plan to go through. And those details often include risk of nutrient runoff to off-site areas that are natural resources like other bodies of water or down into the groundwater. And they're going to do that by assessing your 4 R's. Knowing that that's what they're looking for allows us to collect the appropriate data in the right way. So it makes writing these management plans a breeze, and you can submit them to the NRCS, they can stamp them, and then you get money. Cultra helps a ton with doing that. You're always able to give me a call or write me an email, and I'd be happy to walk through with you your data and maybe put a plan together to submit to an NRCS agent. My name is Jack. I'm the founder and CEO of Cultra, a nutrient analytics platform where we take all of that data we just talked about, we store it and organize it and make it really easy to put into one spot where you can also write your management plan in our software using the data that you've uploaded that's cleaned and organized to make it very easy to write these nutrient management plans so you can assess your farm soil health and make sure your graph of your farm soil is going up and to the right. I hope you enjoyed watching this video. Thank you so much. Have a great day.